Hello, and welcome to the session on architecture trade-offs for global software design. I'm Mike McKenna, and our speakers today will be myself, Tex Texan, and Craig Cummings. Primarily what we're talking about is software architecture and how it relates to building international applications. If you don't have the right architecture, it can be extremely expensive. You'll have your customers finding issues when you should have found them yourselves, and it could be very difficult to make changes later on. So software architecture is not what software you build, but how you build the software. A functional requirement is like a user story. I'm a user, I want a friendly welcome screen that also gives me my status so I have a useful experience. Architecture requirements deal with things like efficiency, modularity, portability. Example here is from an ISO standard 25010, and if you look at the inner circle around the application quality, you see non-functional requirements such as portability, functional stability, efficiency, compatibility, usability, reliability, etc. Many of these carry over for global or international software design as well. We'll take a look at that. So for global software, there are 5 primary areas to deal with: the data, delivery services, application, library, and the user experience. One of the most important areas, we'll go into more detail on that, is the data and the metadata, because to be able to build an application that works anywhere on the planet in any language, it has to be driven by that data. Your user sees the user experience. It has to take into consideration the designs, bidirectional for Arabic and Hebrew audiences, be able to match different devices that you may run into in terms of portability, landscape mode, portrait mode. In the library, you need to have standard APIs so that whatever APIs you use in one part of an experience or in the back end, you can use that same APIs for different experiences. It needs to be portable so that you can bring it from application to application. Key is to use standard metadata. Again, you design your data and metadata first so that all the rest can work together. The application, you want to be able to make it configurable so you can use business rules that may change from region to region, especially if you're dealing with money or privacy or process flow. You want to be able to have rules that can change. You want to be sure it's extensible, because whatever you design for one region, it's bound to be different in another region in another language. For the delivery services, this is how you get your information out, get it translated, get it back in again, how you make sure you have high quality of your product, it's testable, and also to be sure you're using standard metadata that you can draw into your system to help to configure it. Taking a little bit of a look at standards. If you use agreed upon international and industry standards, you can be able to use and create your own software, but also be able to take advantage of a wide range of open source software that sits on top of the same standards. Examples, one of the whole topics around our whole conference, is Unicode encodings. There's BCP 47, which is the language tags and how you pass the names of the languages around. IETF, the Internet Engineering Task Force, and many standards with that, and also with W3C related to internationalization. A number of ISO standards, 4217 for currency, 3166 for the names of territories and regions, 15924 for the names of scripts such as Arabic, Cyrillic, Han for Chinese, Latin for most of your Western European. There's XLIF, the XML for localization interchange, is one aspect for being able to pass messages around. Also looking today with JavaScript at ECMA 402 and all the standard ways in which they are designing the data and interfaces for web applications. Standard metadata, CLDR, the Common Locale Data Repository, for how do you represent various cultural items, such as dates, times, numbers, lists of strings, names of territories, etc. Unicode and the Unicode Character Database, or UCD, for what the various types and classifications are of character types. IANA, the Internet Assigned Names Authority, for time zone names. So you use standardized names for time zones, not just Pacific Time or PDT or EST, but like America/Los Angeles or Europe/Berlin. Also, where do you put that data? Using standard data containers such as JSON or XML with a structure that all of your APIs can agree upon. You want to be sure that you're using an extensible architecture so that you can add features and make it future-proof as you expand into more regions. Do not design for one market at the beginning of your project and assume it will work everywhere else on the planet. Design for the world first and make your initial local product or local region, if that's what you decide to do, as a subset of the world. Do not hard code formats or layouts. You want to build the layout, flow, or formats from metadata. Don't hard code it into your forms, into your JSON, into your React, into your XML, but be able to load it from metadata so that it can conform to what's required for different regions. One example is postal layouts. In the US, you have line 1, line 2, city, state, zip code. But you go to Brazil and you're going to have your street address followed by the address complement, which will be the apartment number on the same line, followed by the barrio or neighborhood, then followed by a city, a state, and a postal code. So you want to be sure those can be configured based on what region you go into. You want to use clear default functionality, so it's very clear what things drop down to if a particular attribute or feature that's asked for can't be found. So let's say you design an application, foo, or API foo, that has two inputs A and B. To be able to make it work with any language, you can be able to pass in a locale, which is what language do you speak and where do you speak it. But let's say you want to be able to support British English in the US. Well, now you have a locale, the British English, to pass in. For instance, on an iPhone you can, or Android, you can set it up to have a British accent if you like. Now you need to pass in a region, so you know that I'm in the US, or I'm in France, or I'm in Russia, but I still want to use British English. In the same light, you may have particular rules that you decide are different from region to region and so on. So be able to pass the rules in as well. Instead of making them hard-coded within your application or your API foo, be able to pass those rules in so that they can be configured by the metadata itself. So don't think about pouring everything into a single application. So foo, let's say it's object-oriented, it can adapt based on the rule that's passed in, but the rule is not hard-coded for all applications in all regions. Another example is extensible architecture. Let's say you're asking for a person's name. So you have first name, last name. Well, that seems to work, but in Japan, you have to enter two names. And it's not first name, last name, but it's your family name followed by your given name. So the family name is first, so the order reverses. And your first name that you enter of your whole name is in Japanese characters. But because many Japanese characters have homonyms and can be pronounced in different ways, Chinese way or a Japanese way, they ask that you enter the yomikata or the pronunciation using katakana. But what if you have users that also need to onboard who don't have a Japanese name? Then you may need to have three name fields or name areas to enter. Potentially the Japanese name, the pronunciation of the name, or the Western name as it would appear, or Latin name as it would appear in a passport. So designing for just one region from the beginning and assume that it will work anywhere on the planet will break down very quickly as you enter into new regions around the planet. So if you make it extensible, then that allows you to be able to adapt to your different markets. The architecture should be configured so that you can make updates without having to change the code. It should ideally be designed so that the content, in other words, the text, strings, videos, graphics, are external from the application, and the metadata that drives the application is also external from it. So it can be configured on a regular basis as standards, customers, markets change, but your application does not have to change. That allows it to be much easier in terms of testability. It's easy to update and allows for automated testing and maintainability. You want to be sure that your architecture is integratable. So you design it to be modular and layered so that more functionality can be added without having to take the whole application apart. Examples are address format and name format. If it's designed in an extensible manner, then it can be used in the front end, can be used in the back end, it can be used for the data structures that you create that can be dropped all the way down to the database.
Let's talk data integrity. So in working at a big data company, in one of my stints along my career path in internationalization, everything was about good data. And there's a lot to be said about data preparation. Data preparation, though, helps the machines learn, helps that AI, helps you make good data-driven decisions, but it is probably one of the most time-consuming tasks you can undertake. And you should start with good data. You should make sure you have good data. You should, if you're preparing data, ideally you start from a good foundation. That foundation should be Unicode. Particularly if you have a web-based business. Unicode is the encoding of the web. Unicode internally should be, your processing du jour, and all internal processing should be Unicode. And where you have, you could have older data. It could be good data. It could be in a non-Unicode encoding. That's okay. You can convert that into Unicode and do your internal processing, but make sure, that encoding goes well. You can even switch between Unicode encodings internally. That's algorithmic, it's fast, and in certain cases, it's actually more efficient. But whatever you do, ideally, start from good data, even if it's not Unicode, process in Unicode, and ideally output Unicode, particularly if again, if your business is web-based, you should be outputting not just Unicode, but UTF-8. That's the encoding of the web. For other applications, it may depend, but ideally you're running Unicode as well. There is a case where you may not know the encoding of some older data, but it's good data. And you want to convert that to Unicode. And there are heuristic ways, that's a fancy word for guessing, to convert from something that is not known into something that's into Unicode. But you may or may not have the best luck in trying to do so. Ideally, you have some metadata, some information about just what that data might be, even if the encoding is not explicitly marked or known. Maybe you have some hints, maybe you have some other information that will lead you to a good decision about that data, and you can get to the good data piece. And with good data, and ideally with some good code and good practices, you can work better in the globalization software development lifecycle. And so here's sort of a bit of a snapshot of some of that lifecycle and more automation and more tooling and how that data integrity will work well for you. So in the development stage over here, you can start out with, you can left shift and you can analyze and you can assess, and you can do some things that will tell you just how well, a globalized product you will produce, how well internationalized, how well localized it will end up being. You can do some things early on that will save you from finding problems later in the testing cycle where it's often too late to go back and fix things. But even in the testing cycle, I have, and for the development and for the testing cycles here, I've given some presentations about, take a look at the iMug presentations that I have about, static code analysis and parallelized, internationalized testing and APIs, services and APIs, and things that will set you up for success. I haven't talked much about machine learning and AI in the process of globalization, but there's some opportunities there. So think creatively, think outside the box. AI and ML are not going to solve every problem you have, and I don't encourage throwing them at every problem. But there are some opportunities here for it to make the process, the life cycle more efficient. And with good data that ML likes to train on, all the better setup you will be.
Let's talk about usability as it affects your architectural requirements. So there are a number of issues. There are, of course, the cultural differences around the world. I'm sure you're all familiar with those. But there are also physical differences. The devices that are available and used around the world changes significantly with respect to form factors, resolution, speed of the devices, and the capacity for storage. Communication similarly has significant differences in speed, availability, reliability, and most importantly, cost as well. And in some cases, the ownership of the device is a factor. Some users can own their own devices, but in some parts of the world, they only have access to public computers, and this can affect the design of your software. In some cases, you might have to take into account government monitoring of how the applications are used. Now, the implication for the design process is that globalization should be everyone's responsibility. This goes for the designers of the application up front. They should have some global intuition and experience. And it, of course, affects the development, QA, and even the IT organization, because they have to think about the deployment and whether or not a wide area network is needed, whether a CDN network is needed, and those are factors to take into account. Globalization should be designed in as early as possible, and most importantly, there needs to be a process to ensure global design. This, for example, could include having in-country reviewers or designers to influence the process, the creation process, and having designers take into account global requirements. An important aspect that's often overlooked is to include localization or people with knowledge about different country requirements at the Agile management table. The people controlling the development process and making decisions about what should be included in each sprint. They also should be thinking about what does it mean for different markets, and is there adequate testing and controls and review going on. Another step that can be taken is to ensure that there's a post-mortem report which takes a look at the end of the development process, and maybe even including 6 months or a year out after deployment, to take into account the bugs and maybe recalls or problems that occurred in the field, and to collect all of that information and provide recognition for those decisions that were made in the design or in the internationalization of the application that resulted in avoidable localization costs and delays to market or recalls, and feed that back into all aspects of the development process and the organization, not to assign blame, but to look at how those problems can be avoided going forward. It's important to recognize that the one design fits all, the monolithic application often doesn't work for global design. You have to adapt your functionality and your user interface to device capabilities and to the cultural differences. So to do that, you might consider lowest common denominator design, but that's very limiting, and it only works for the most simplistic business applications where you're collecting a small amount of information for limited types of transactions. For most applications, you can't make use of that, and multiple designs and layouts are required according to in order to satisfy the need for different workflows, for different types of information being collected, and how the information is presented to the user in culturally different ways. So you're forced to consider having a global design to try and accommodate that, or to have a different design for some markets. And in order to do the latter, you can consider having a dynamical layout where the screen and the UI adjust according to the data that's being presented. That's often not very aesthetic and requires an intense and amount of QA. It can be helped if you have prepared templates and you make choices as to which template to use for certain markets. Another solution is to have standardized UI containers and components where the data that you're presenting goes into constituent components, and you compose the entire screen of these containers. And examples are, for example, where you have a card layout or a newspaper layout broken into columns and boxes on the screen that your data fits into. You can then usually have a little bit more dynamic layout within those, and you're constraining the number of permutations of how you present data to users with that approach, and that simplifies the QA and is a little bit more accommodating. But this leads to questions of, where is the layout determined, whether you can have enough CPU capability and storage to do it on the client's device, or you have to make the decision on the server, which can complicate your server logic. And there are issues of installation as well, whether you're going to have an application that installs for all locales or just a particular locale, and there are a number of issues around that, including the rules of the app store that you use to deliver your application if you're going through one. Another complication is user-generated content. If your application is accepting information from users and maybe sharing it with other users, this imposes a significant number of architectural requirements, such as being able to tag the content for the language of the user and the region where it's coming from, so that other users that have preferences for language and whether the content might be relevant to them, and to be able to match that. It also imposes a number of regulatory compliance requirements by region, such as what is considered hate speech or pornographic in those markets, what is the age of maturity perhaps for certain types of information, and to respect your younger users, children. You can have accessibility, and then requirements as well as other privacy requirements if you're dealing with financial data or health data, for example. You also need to manage information about users where they were requesting deletion of data. And so you have to build a part of your architecture to be able to manage that and accommodate those requests. So this slide and the next slide is bringing out the issues of users in different markets and whether or not they want to see information from speakers in the same language but from other countries, or in other languages, whether they're multilingual, and the legal requirements for that. So this imposes a number of requirements on your architecture, and you have to take into account you're going to be dealing with many different types of stakeholders now. So you have to have the structures to be able to address that, including to be able to detect spam and those types of issues, and to have QA processes that can confirm that your system's working the way you expect. Also, when you're dealing with user-generated content, you have to take into account which characters, which scripts, what kind of data you want to allow in fields. So for some fields, it doesn't make sense, for example, to accept emoji. If somebody was providing their name, perhaps you don't want to allow emoji characters. In other fields, it can make sense. So there are those things to think about. So with all of this complexity, you have to anticipate errors in your architecture. Can you detect errors? Where in the process, whether it's in development or at runtime, that you detect that errors exist, and then when you have errors, can you diagnose the source of the problem, and how easy is it to repair those issues? When you're actually deploying, do you have a system for real-time monitoring for how the application is functioning, and whether it's working as expected, throughout all of the markets that the application is running in? It helps to be able to compile this information, have a dashboard, and be able to do various kinds of analysis, statistically and historical, as well as real time, for all of this information. Because this will guide you in your updating and replacement strategies throughout your applications, to know which components are most problematic, which tend to fail. Also, it can be enlightening about the development teams and their ways of working, who needs more education perhaps about internationalization, and also to consider revising your development processes. There are all kinds of diagnostic tactics, and these are at the source level, where you can have some automation of detection, development level, and deployment. So consider all of those types of things, and build in checks within your architecture to be able to catch problems as early as you can. Your applications are going to make use of data that is driven by global standards. There are a number of these, and so here's some of them: time zone data, postal and map data, and many people assume that this is data that changes rarely. Something like time zone data, you wouldn't expect that to change with some frequency. In the United States, we've had a change several years ago where we changed the date for switching between daylight savings and standard time, for example. So people have the impression that these things might not change too often. But around the world, these things do change with some frequency every couple of months. At least, and so all of your standards may change, and your architecture and development processes should accommodate updating this data. And the significance of that data is changing is also it can affect your current data. So you have records, and it has timestamps in there, and the times for scheduled events. And when the time zone, for example, changes, you may have to find the records that are affected and change those to reflect the new time zone rules. But it may not be obvious, and it may not even be possible to do this entirely automatically, to convert the records to the new time zone. So you need to have a process for identifying the places where the data is changed, and also, in some cases, maybe even go back to users to get them to confirm which way to change the data, keep the old rules or the new rules for the particular date and the type of usage of that date. So that's an important thing that many people don't take into account, and need to take into account when they're dealing with global data. So you want to define tests for these things, and you also want to design your architecture so that you can accommodate these changes even in your API and your schema, to have some versioning to identify the standards that are being used if those need to change. Then, because not all parts of your system may not change at the same time, or if you're integrating with third parties. So in order to be consistent, you may need to have some additional meta information around the data that you're sharing, and to be able to do conversions as needed. And then finally, we have to take a look at performance. And there are some things you can do when you reframe tasks in ways to avoid localization requirements. They can be linguistic requirements, they can be other related requirements. And there are things you can do to reduce, for example, message formatting requirements, and to simplify searching and sorting of records, and where this searching and sorting occurs, whether it's on the client or the server. All of these things are things you should take into account in your architecture, and you may need to have an architecture that allows you to change based on the circumstance. For some regions of the world, you may want it to work one way, and in some parts of the world where they have different speed and performance or cost functions to observe, that you can reconfigure for those. And these requirements also often change around the world. So you need to be able to reconfigure your systems either dynamically or to have rules to accommodate those kinds of changes. Some of this can be accomplished by identifying frequently used data and compiling data based on static and runtime analysis, compiling and indexing the data using appropriate structures. In many cases, granularity is your friend, and breaking data up into smaller chunks and distributing how it's processed in smaller chunks with REST API and the like can give you more throughput and also many opportunities for parallel processing and processing in the background. So those are all things you can think about. And finally, you're going to have some surprises when you, if you don't do last mile testing. With last mile testing, you can learn about some of those surprises before they cause you problems in deployment. So things that you think work well in your market and aren't going to work well in other markets can only be discovered with testing in those markets. So try to establish in-country testers. This can be done with kind of friendly family type testing, as it's called, where friends of or intensive users that are in those countries, bring them into your beta process and your early release process to learn about problems that you wouldn't otherwise discover without some of that testing at the, as it's called, the last mile. So with that, we wanted to leave some time for questions, and so I ran through this a bit quickly.